Hey everybody, Mark Bates here, and today I want to talk about a few of the different interfaces in the Standard Library's FUMPT package that we can use to format our types in various ways that can not only give us great insight into our types, but actually allow them to be more usable in different scenarios. So to start with, I have a very simple type called Beetle, and a beetle represents, well, one of the Beatles. So we have a name, an instrument, and a quote. So inside my main function here, I've got a new Beetle with the name of John, an instrument guitar, and a quote of imagine all the people. And I'm assigning it into this variable B. And then finally, I'm printing it off using printf and the formatting verb %s. And let's look at exactly what %s is. So if we look at the documentation for the FUMPT package, if we scroll down a little bit, here we go. We see string and a slice of bytes treated equivalently with these verbs. So %s is the uninterrupted bytes of the string or of the slice. That is obviously a little rough around the edges in terms of wording. So let's just look at what that actually does. If I were to run this example here, what I get is Go's best guess as to what the format of a Beetle should look like. And what it does is it just basically wraps everything inside of it, all of its fields, by calling their %s equivalents. So in this case, they're all strings. So I'm going to get John, guitar, and imagine all the people, and it's just going to wrap it around some quotes, curly braces here. And that's not really what I want. I wanted to say John plays guitar. I wanted to kind of have a nicer implementation of that string when it gets printed off. So how do we do that? Well, one of the ways we can do that is by using the FUMPT stringer interface. Now, for those of you who are unaware of what the FUMPT stringer interface is an interface in the Standard Library that says if you implement a method called string with a capital S that returns a string, you're implementing the FUMPT stringer interface. This interface is called when you pass your type to, say, FUMPT print or print line or sprint or any of those kind of other equivalents. It's going to look and see, do I have a stringer implementation? If so, I'm going to use it. So let's go now and add a stringer implementation to our Beetle type. And to do that, I'm going to add a method on my type of Beetle called string, and it's going to return a string, and I'm going to return FUMPT sprintf. I'm going to do %s, and that's going to give us be John, and we're going to say plays %s, and that's the instrument now. So I can say B name, B instrument, and if I were to run it this time, now I get a much nicer output. John plays guitar. So now, let's see what happens when I change the formatting verb from %s to %q. If I run it this time, I get a quoted version of John plays guitar, and that's slightly better. That's more akin to what we would normally expect it to be. So what it's going to do is it's going to take our stringer implementation and then just quote that for us. But what if we don't want a quoted version of our stringer? What if instead I want to change John plays guitar to John said imagine all the people? How do I go about doing that? Well, we can do that by implementing the formatter interface. Again, from the Standard Library FUMPT, this formatter interface is a method called format that takes two things. The first being a state. Now, state is actually an interface here, but probably the most important thing on state is that it is an IO writer, which means we can then write our formatted information into it. And the rune is the verb. So think when we say %s, the rune would be s. When we say %q, it's going to be q. %v, it's going to be v. So knowing this information, how do we use it to change our functor? Let's go back to our type here again. And this time, let's go and actually implement that formatter. So on my Beetle type here, I'm going to implement a new method called FUMPT, and it's going to take a FUMPT.state, and it's also going to give me back a verb, which is a rune. And so what I'm going to do now is I'm going to put a nice little switch statement in there that's going to switch on that rune. And my default statement, so we always have something to fall back on, is going to be the stringer implementation. So I can say f print here, and that takes an IO writer, which we know our state is, and I'm just going to call the Beatle stringer implementation. Now, if I run this again, I get John plays guitar, but I'm asking for a quoted version. So I'm not getting the quoted version because we're just falling into the default of our format statement here. But if we add a case on Q, now we have something different. So this time I'm going to say funct f print f, and again it's going to take the state here, but now we need a formatting string, so I'm going to say %s, so John said %s. In fact, I'm actually going to change that to a Q. There we go. And so I'm going to say Beatle name is John, and then I'm going to get the quote. So now if I run this example, now I get John said, in quotes, imagine all the people. So now we have added both a %s and a %q implementation for our Beatle. So let's look at another couple of these verbs. And particularly we're going to look at %v, which according to the Go documentation in the FUMP package is the value in a default format. So what is the default format for our Beatle? Well, we don't really have a good one. So instead, I would like to use JSON as that default format. So let's go back now and add another case, this time for V. And what I'm going to do now is I'm going to say JSON new encoder, giving it an IO writer, in this case our state, encode our Beatles. So now if I do %v, if I change this down here to %v, hopefully I will get a JSON output. And look at that, I do. I get the default JSON output. So I can now switch between these three different ways of viewing my data, which can be incredibly useful for all sorts of things, not just for debugging, but imagine using format to change how you display text to display the Beatle to an end user versus, say, the Beatle to a log, the Beatle to some other information. But I'm going to take this even one step further, and I'm going to add support for another one of these verbs, and it's this one here, %v, a Go syntax representation of the value. So what I want to do is I want to make it so that when I print using %v, I get kind of this, right? I get something that looks akin to the implementation of Beatle, what we'd actually have to type out inside of our main function. So how are we going to do that? Well, we're going to use one last interface from the FUMP package, and that's the Go Stringer interface. And what the Go Stringer interface does is it has a method called GoString that returns a string. And if we look at some of the examples here, what it's really trying to do is give you kind of a Go representation of what that type might look like. If I'm going to open this up in the playground here and run it, you can see that we get a fairly kind of Go-ish look at this data here. I'm going to take it a step further and actually make it look like this. I'm actually going to put the new lines in there as well because I'm crazy for that sort of thing. So let's go and do that now. So off screen, I have implemented the GoStringer method here. So I've got a method called GoString, which returns a string, and I'm going to use a bytes buffer, and I'm basically going to write out the implementation for it. So I get Beatle, open curly with a new line, and then I'm going to use the tab writer to neatly print our fields and their values out. And then finally, I'm going to write out the final curly brace here. So inside of our format method, we still haven't hooked it up because right now we're just saying if you see V, print off the JSON representation. But now we need to actually check the flag. And so I'm going to ask for the hash flag here, and that's actually a rune like such. And if it has it, I want to return because I don't want to actually encode the JSON. Instead, what I want to do is I want to call funct fprint here. Again, I'm going to give it the writer, and this time I'm going to give it the Go stringer. So now if I change to use %#v, I should now get something that looks much more like a Go initializer statement here. So if I run this, well, look at that. That's exactly what I got. This is copy and pastable code I could probably use. The difference being we still have one last bug, which is these should all be quoted. So let's change this to a quote here. And now, look at that. I actually have the correct types that go with it, and I could take and print that information straight back out into an actual viable piece of Go code. So with all of this, I have really increased and changed quite dramatically how I can work with my Beetle here and how I can format my Beetle. And this gives me some really kind of fun stuff, because one thing I can do, for example, is if I were to say wanted to rewrite this code, I could simply grab, say, the Go string implementation here. Now I've got a Go string. Or I could also call sprint f here, and this is going to give me back a string that I can use in my code that does whatever I need it to do in my code. So understanding this level of formatting, as well as the interfaces that the funct package offers you, really helps you be very expressive with your types. So in a relatively short amount of code here, if we just look at this, we've got these three functions. The first being our funct stringer, which delivers a very basic, simple implementation of what our type should be. Then we have our funct Go stringer implementation, which slightly more complex, but only complex because in this particular case, I wanted to make it a bit more complex and have nice tabs and new lines and everything kind of nicely quoted and aligned. But I didn't necessarily have to do that. I certainly could have done it all in a single line here, but I liked it breaking down. And then finally, the last thing we implemented was the funct formatter interface, which has now allowed us to look at all of the different flags, formatting verbs like %v, %s, %q, as well as any flags, modifiers to those, like %#v, for example, or %+v. We could also enable that if we wanted to. So understanding all this means we can now really make very tight, expressive types and keep the rest of our code really simple and straightforward, because it doesn't need to know about all of these different ways to format. It can just ask for kind of standard formatting verbs, and we have implemented them the way we want them. And of course, the final benefit of all of this is all of this is done without reflection, in our code anyway, and it's all done simply by implementing a few different interfaces. So with that said, I know this was a weird kind of meta topic here, but I really hope you enjoy it, and I hope this helps. This video was brought to you by Gopher Guides. If you are an organization, conference, or user group looking for Go training, please visit gopherguides.com. For more great videos like this one, please visit gopherguides.tv.